So, chapter 4. So, chapter 4 deals with the first and second derivative test. So, let's see. So, first derivative. If the derivative is positive, then the function is increasing. If the derivative is negative, then it's decreasing. And then in terms of the second derivative, if the second derivative is positive, then concave up. And if the second derivative is negative, then concave down. Right? So let's look at an example as to what the first and second derivative test can tell us. So let's do this one. So f of x equals x cubed minus 6x squared plus 9x plus 1. So let's do our first derivative. So that would mean f prime is going to be 3x squared minus 12x plus 9. Right? So the first thing we want to do is find our first derivative. Next step is we take the first derivative and we set this equal to 0. And we want to see if we can factor this. And so if I do, we get a 3x and an x, and then it'll be a minus 3 and a minus 3 by factor. And then I can take each one of these, so either 3x minus 3 equals 0, or the x minus 3 was equal to 0. Solve each one of these, so here I'm going to add 3, and here I'm going to add 3. So this is going to give me 3x equals 3, and this one will give me x equals 3, and then here I can divide, and x is 1. Right. So we have that. So now that we have those numbers, the next thing we want to do is we're going to make a chart here. So I'm going to have over here my numbers I just found, which were the 1 and the 3. So we have this sort of number line, right? And then I have my factors, which was the first one was 3x minus 3. This was x minus 3. And then this is my derivative, right? So now what I'm interested in is the sign of the number. Okay? I don't care what the number is, just what the sign would be. So first off, we want numbers that are less than 1. If it helps you to pick a number that would fulfill that requirement, do so. So let's pick a number that's less than 1, 0. Well, let's see. 3 times 0 minus 3, well, that's a negative. 0 minus 3, that's also a negative. And then a negative number times a negative number, well, that would give me a positive number. Okay. Now we go to the next interval, which is between 1 and 3. And again, if it helps you to pick a number, do so. So let's say if we were to pick 2, well, if I plug in 2 into that first one, that ended up being 6 minus 3, which is positive. And then 2 minus 3 is negative. And a positive times a negative is a negative. And then we pick a number greater than 3. And on this side, everything would be positive, right? So what does this tell me? Well, this tells me that here it is increasing. Here it's decreasing. And here it's increasing, right? Now, this also tells me something else. This tells me that this is going to be a relative max, and this is going to be a relative min. Because basically this is what's happening in terms of roughly a graph of what this will look like, is we got something that's going like this. It was increasing, it turned, it went down, and then it went back up, right? And so this is where we get our max. This is where we're getting a min, right? And then we could get the corresponding y values for those 2 points. So we could plug in the 1, we could plug in the 3, and we could get the y coordinate. So that's what that tells me. And so this would come out to be, actually, if you did this, would be the point 1, 5. And if you did this one, you would get 3, 1. If you plug that in, right? So now we get to the second derivative test. And so now we start with our first derivative, which we said was 3x squared minus the 12x plus 9. So now we take our second derivative, which will be 6x minus 12. And now we take that, we set that equal to 0. And again, we're going to solve for x. So we get 6x is going to equal 12, and then we divide. And x is going to be 2. And so again, we can build another chart. This time we just have the one number here, which is 2. And we have 6x minus 12. And my second derivative. So if x is less than 12, this will be negative. And my derivative will be negative. And then if we're greater than 2, this is positive, and this is positive. So this tells me it's concave down. This tells me it's concave up. And then at 2 is where this curve is making this switch, right? So you got a biliary curve was going like this, and then it goes like this, all right? And so we call this point in here the IP, or the inflection point. So 2 is the IP. And again, we can plug in and get the corresponding y value that would go with that, right? So that's what we can get from our first and second derivative test. So we can tell in terms of where is it increasing, decreasing. We can get in terms of relative maxes and mins for that. And then the second derivative test tells us something about the shape of the curve, whether it's concave up or concave down, and then where that inflection point would be. So let's go on. All right. So then we get in terms of back to derivatives a bit, right? And L'Hopital's rules. Which says if the limit as x goes to c of f of x is equal to 0, and the limit as x goes to c of g of x is equal to 0, then the limit as x goes to c of f of x over g of x is going to equal the limit as x goes to c of the derivative of f of x of g of x. Right? So let's do an example. What does this mean? So we want the limit as x goes to, in this case, 0, of e to the 4x minus 1 minus 4x over x squared. Well, the first thing we want to see is, does the rule apply? So we need to look in terms of just the top and in terms of the bottom. So let's do that. So I want to know, what's the limit as x goes to 0 of e to the 4x minus 1 minus... Well, it ends up, yes, this will be 0, because after all, e to the 0 is 1. 1 minus 1 is 0, and of course 4 times 0 is 0. So this is indeed this. And then we look at the bottom one and say, okay, is it true for the bottom? And of course here, yes, it is. So the rule applies. So now the rule says, okay, take the derivative. And so we can take our derivative. So we want the limit. So this is going to be 4e to the 4x minus 4 over 2x. Okay? Well, if you look at this again, you should notice that if I do this for the top and bottom, you should see that both of those go to 0. Because e to the 0 is 1. 4 times 1 is 4. 4 minus 4 is 0. And then, of course, 2 times 0 is 0. So could end up with this rule, you end up having to apply it again. So we're going to apply our rule one more time. And so now we get here 16e to the 4x over 2. And so now we get something we can get. After all, e to the 0 is 1, so this is going to be 16. The bottom part is 2. We get our answer of 8. We can also do the same thing for when we're talking about infinity. So this. So the limit as x goes to infinity of 3x squared plus 5x over 4x cubed plus 7, right? So we can do the same thing here. And we can say, okay, well, if I look at the top by itself, we can say, yep, this is going to be infinity. If I look at the bottom by itself, we can say, yes, this also goes to infinity. And so again, we can do the rule again. So now this says, okay, do the rule. And so limit as x goes to infinity. So this is going to be 6x plus 5 over 12x squared. And again, of course, top and bottom are both going to infinity. So I could do this one more time. So this is 6 over 24x. And now my answer will be 0. All right. So other things you'll see in this is going to be a thing called the extreme value theorem. which is this. So a function f that is continuous on the interval a to b has both an absolute max and min on that interval. Right. So let's just look and see how does that work. Right. So let's do this example. Right. So let's say f of x is given to be x cubed plus 3x squared minus 9x minus 7. And my interval is from -6 to 4. So what this says that we need to do is we first want to evaluate at the endpoint. So we want first the f of -6, which will be -6 cubed, 3 times -6 squared, minus 9 times -6 minus 7. And we do this, we get -61. And then we do the f of 4. And this will be 4 cubed, 3 times 4 squared, minus 9 times 4, minus 7. And this gives us 69. Okay. So we do those first. And then we're going to find our derivative. So f prime x, which is going to be 3x squared, 6x minus 9. Take that and set it equal to 0. All right. And then let's see, we can factor 3 out. So x squared plus 2x minus 3. Right. And so this is going to give me x plus 3 and x minus 1 when I factor. And then, of course, either x plus 3 is equal to 0 or the x minus 1 is equal to 0. So we can solve each one of these. And so this is going to be -3 and this is going to be 1. Right? And so now what we want to do is we want to evaluate our function of those 2 points. So we can do the f of -3. So this is -3 cubed, 3 times -3 squared, minus 9 times minus 3, minus 7. This will give us 20. And then the f of 1 is 1 cubed, 3 times 1 squared, minus 9 times 1, minus 7, and this is -12. Right? So now we look at our numbers. We got a -12, we got a +20, and then up here we had a -61 and 69. And so, based on all those numbers, we would have that this is the absolute min, and this is the max. Right? Right? All right. And then the last types of problems it talks about are optimization. And so for this, let's just do an example of one. So given something like this, that P is given to as 500 minus 0.4x, and the cost is given to be 20,000 plus 20x. Okay? And then, of course, revenue is given to be P times X. So revenue function is 500 minus 0.4x times X. So my revenue function is 500x minus 0.4x squared. Right? And so we have our revenue function, we have our cost function, which of course means we can find our profit function. So P of X is the revenue minus the cost. Okay. And so we simplify this and we get what will be 480x 0.4x squared minus 20,000, right? So now we have all those numbers. Let's look at some of the things here. Well, let's see. Let's first find maximum revenue, max revenue. So we got our revenue function, which was Rx equals 500 minus 0.4x squared. And 500x, sorry. Okay. So we can find the vertex. And so I will put this into the normal form, which would be 9 is 0.4x squared plus 500x. And so this would be a minus 500 over 2 times negative 0.4. This would be 500.8. So 500 divided by that. So this comes out to be 625. So this would be 625 units sold. And the revenue, so R625 is going to be 500 times 625 minus 0.4 times 625 squared. And this comes out to a revenue of 156,250. That's the revenue. Okay. Well, we can also look in terms of profit. What's the max profit here? So P of X, which we said was 480x 0.4x squared minus 20,000. Okay. Yeah. And so we could look in terms of, let's do this one by our derivative. What's the derivative of x? So that'd be 480 minus 0.8x. Right? Well, let's take our derivative, set equal to 0. 480, 0.8x equals 0. Bring the 0.8x over. So 480 equals 0.8x. Divide by the 0.8. And we get x is going to be 600. Right? And so now, of course, we can figure out what is the maximum profit. Right? And so P of 600 is going to be 480 times 600 minus 0.4 times 600 squared minus the 20,000. And we get this is going to be 124,000. Right? Right? We could then figure out what would be the price that gives us the max profit. And so P would be 500 minus 0.4 times 600. And so this would be 260 gives us that price, right? And that will conclude this video.